All right, so hello everybody. Thanks for coming. My name is Mark. This is the Testing Sea Monster talk. You probably read the description and know what you're in for, but just so you know, this is a children's story format talk about front-end testing. And sort of the background here is I wrote this thinking back on how complicated and intimidating I found testing to be when I started to get involved in it. And so we're going to go through some types of testing. We also have a little bit of help here. I'll do this little stuff about myself. I work at Cypress. I'm also involved in People Making Progress. That's a nonprofit based in Tucker, Georgia. They do developmental disability support for adults with disabilities. It's a great organization to support. I know that the room label was wrong, so if you came here thinking it was a different talk, this is a good time to bail or stay and have a weird time with us right now. So the last thing I want to talk about is refcode.org. That's an organization that works with refugees and immigrants. It's based in Clarkston, Georgia, but anybody here can volunteer online or in person. And that organization teaches early career coding skills to those folks, helping them figure out if programming is something they're interested in doing. We have some help doing the voices in this story. This makes me feel so good to have people to help out with reading this and working through this with you. So Cecilia, Will, and Abby are going to take part in this. Thank you very much.
Aye, Captain.
There's quite a bit of content in these slides later and examples and stuff. You're welcome to grab them if you want. I'll put this link back up again at the end. If you want to follow along, that's fine. And, they're there if that's something you're interested in. So we did the About Me. Now it's time to learn about yourself. You are a junior crew member on the SS Front-End Development. You're setting sail to deliver yet another quality feature on time and under budget. It's a beautiful day. Your ship starts moving on a calm and quiet sea, and the crew gets to work. All around you, people are busy building up basic components and reusable helper functions required for the feature you're delivering. After a few days of travel, the water gets a little bit choppy. There's no obvious cause for this, but something makes you nervous. A tentacle rises unseen through the waves, and a strange voice carries on the wind.
Ha ha ha, you fools! All of this development and not a single test written? The ship will almost be too easy to send off course.
The ship leans back and forth, producing an unpleasant queasy feeling amongst the crew. Unsteadily, you approach the captain.
Captain, how about we write some unit tests for all this new code? It will make things a lot more stable around here, which is good because I had tacos for breakfast.
Say no more. Let's unit test everything and get 100% code coverage. After that, it should be smooth sailing.
Highly confident captain. Thank you. Unit tests and component tests. So I start out with these two things together. These are the sort of most foundational building blocks of testing software as you're developing it. You may have heard about the testing pyramid or the testing trophy. There are a lot of different mental models that we can use. In this talk, we're going to sidestep those types of discussions and really get into situations where you might use one or the other, rather than trying to find something that works for every situation. When I think about unit tests, I'm considering testing a single conceptual unit of business logic in your application, like a function that does a calculation and returns a value. Maybe it has a bunch of logic in there. Maybe it even calls other functions, but it's still a single unit in terms of what your application does. We call a function, we assert the value that was returned under various conditions. The benefits around unit testing are that these are really fast to run. You're generally just calling, if you're doing web development, you might be calling JavaScript functions. They'll be really snappy. They list out the reasons for that function to exist, like what's it doing in your system, what is it supposed to do, and you don't need a browser to run these. This becomes important when you compare them to component tests because a lot of things that are pure business logic, you can get away with looking at those without a browser. Component testing, on the other hand, is a way to mount an individual component from React, Angular, Vue, something like that. We're going to put that into the browser in an isolated environment. We can test it, you perform interactions after it mounts, just see everything that's going on with it. It's also a really good place to test accessibility. If you have a component library, that may be something you're already doing. And my recommendation is don't spend time unit testing the internal pieces of a function that are part of a component in the browser. So if you already have component specs and they reach in to test like methods or computed values on your components, that's really executing JavaScript in the browser that's not really doing something that's UI-based. You might be able to pull that out into a regular unit test without this. But same set of benefits. We're going to document what individual components are responsible for in the system. And when you do execute them in a browser, you can see your component up and running. You can use dev tools to inspect it, and you can kind of work with it that way. So let's take an example of unit testing. We'll just ignore this. OK. So this is a unit test that is testing add two positive numbers for a function. And let's take a look at the function itself. Actually, let's grab the test first. So we can see here a describe block and several little tests within it. This is just saying this function adds two positive numbers, and we're going to call it and assert that the result is 5. When I add 1 and 4, the result is 14. When I add 10 and 4. These are just testing like the happy path of the function. And then we have a couple of tests here of like what errors is it supposed to throw? Like what should it do if you give it invalid information? So this is highly simplified. Make it a little bigger even. But this is the kind of thing you can test with a unit test and very common way to think about it. We can see our test is failing though. It already says expected -3 to equal 5. That's obviously wrong. So the result of this test is a failure. Right now, we are running this in Cypress because that's what we're going to use for our examples, but this would be the same if you ran it outside of a browser. And we can see if we look at why this is failing, I've made some code changes here. It's got a minus instead of a plus. We could fix this, and we could rerun the test and see what happens. And that's the general value of testing like this. One side of it is test-driven development, so you can specify the behavior before you write the code, kind of have nice feedback cycles like that. The other is if you did what I did here, which is pull down some code and then break stuff, you can find that out by running the unit test to see if you broke like the expected contract for that particular function. And then we can see that the function is still working in these other ways. The next example we'll look at is a component testing example. So here we have a button component, and we can see it's also failing. Cypress is trying to find a button called Click Me, and it looks like it's there, but the button is not actually showing up, right? We're saying we wanted to find Click Me within the selector button, but we didn't. And it's the same thing where I've written an assertion about what's supposed to happen. Instead of actually like calling a JavaScript function directly, we're mounting a component, which is a really similar experience. And we're able to say the command here, CIDA contains button click me, should be visible. So this is really similar to just calling a function and asserting the result. However, it's not working. So we're going to look into why is that failing. And it's because I have a div instead of a button element here. So when it tries to match the content click me inside of the button element, it's actually not possible to do that. And the way I'll show this as well is to say, well, we're not sure what's wrong. We can inspect the DOM, and we can say, oh, look, it rendered an element. This wouldn't pass the test, right? So if I save my file, rerun that test, it's passing now immediately. And we can see that in the DOM, it actually rendered a button element. So buttons are better than divs for accessibility. You get a bunch of free keyboard behavior when you have a button. Tab key works, spacebar works, enter key works. Screen readers get announcements about the nature of what the button is and how to use it. So in my component tests, I really like to specify the actual HTML that's coming out of the component in as much as it matters. So if there's divs and containers and wrappers, I don't write them out in a component test. But if something's supposed to be a button or a link or a form field, I generally tend to select by the element itself. This is a great thing to get right in components because then when you use them later on, you're going to have good accessibility because you're building with accessible building blocks. So why would we focus on accessibility in component tests? Just like unit tests, they're fast. They're faster than the next level up we're going to talk about. So as soon as you mount a component and test it, this is the lowest level where you can start to see accessibility problems. Generally, a component test is written by an engineer, not someone working in QA after something is built. So when you're writing the component, you're making decisions about markup and what you should use. It's a great idea to put that into your component test so you can prevent regressions. This also is a really good way to get a single source of truth for accessibility. You do not rely on having end-to-end tests that are kind of user journey based, flowing through different parts of your application, and on the fly testing accessibility around those parts of your application. If you can cover it in component tests, it's a really good place to do it. The reason that we want to focus on accessibility, for me, is I see this as important for our applications to work for all users. Your companies may have legal obligations, compliance things as well, but that's the core of it. To me, the front-end quality aspect of accessibility is like the foundation of all other good things in front-end. If the code is accessible, we can understand it easier, we can have a better experience, and it's really important to me. So this is why I think getting it right in your components at development times is great. But also, we work at companies, and in many ways, we can see that the company's purpose is to ship HTML to people. Like you have a big, complicated, expensive set of machines, you have databases, you have API calls. Everything is about getting the HTML to the front end so users can experience your application and get the value from it. And I think it's important that we ship the right HTML that works for the most people. My example of this is that our companies are a bit like Netflix and the packaging used by Netflix, and our applications have all these things there. And if we're shipping inaccessible HTML, for about 10 to 20% of people, that might not work. And I don't know if you can see, this is the M. Night Shyamalan movie, Unbreakable, that's in the DVD here. And sometimes it happens. So this is my representation of inaccessible code, right? When we're sending out inaccessible code, for some people, this is what they're getting, and that wouldn't have been a good reputation for Netflix. We've been using this Cypress tool for our examples, so that's where I work. I'm an engineer at Cypress. There's two parts to it. I want to briefly tell you what you're looking at. One is the Cypress app. That's the local thing that we've been using. This can run end-to-end tests. This can run component tests, and it's a fairly popular testing solution with about 5 million downloads per week. The other side of this is the Cypress Cloud. This is our paid product, although it's free for open source, and we have a free tier if you want to test it out. This has a bunch of different features. We're not really going to have time to talk about them, but that bottom bullet there is my favorite thing. That's what I'm working on right now, is the accessibility stuff that's coming. So I will have a link. If you want to learn more about that later, you can. Okay, anyway. As soon as you reach international waters, there's a rumbling from below, and a giant sea monster appears.
Shh. Unit tests don't prevent bugs. Haven't you seen the meme with the sink?
If you have not seen the meme with the sink, this is something people sometimes use as an example of dismissing unit testing, right? You've covered your spout and you've covered your pipe to take everything away. But this is still not perhaps the desired end result. So sometimes we will dismiss a form of testing and say, well, it doesn't work for preventing everything. And this is one of the many examples you can find of memes related to that.
Let's go home. Testing was pointless and software was a mistake.
As the crew turns the ship around, you start visibly shuffling charts in the hope of looking busy and not being asked to do anything. All of a sudden, a map falls out that shows the path to end-to-end testing.
Captain, what if we go here? It says we can deliver the feature with confidence if we use end-to-end testing.
By Jove, I think she's got it. Turn this ship round, head to end-to-end testing.
All right, we're going to compare end-to-end testing to component testing. And this is how I felt when I would learn about some new testing concept. I'd be like, oh, this thing solves my problem. Let's do all of that now. So comparing these two, we looked at component tests and unit tests and how they're similar. With component tests, when I compare them to end-to-end tests, I think about component testing as way more vertical. We're picking up a component, we're looking at how it works, and really thinking about the component as an entity and what it's responsible for. We're testing a single node of what is probably in practice a whole component tree that your user will interact with. And that means we're testing it from a user perspective in terms of how it fits into that. But also, in order to mount it and use it, we have to know some developer-facing things. We're going to use prop names. We're going to use things that are exposed for consumers of that component. And that's actually really useful, because if that component gets used in another part of your application, its contract includes what are the prop names, what are the events that it emits, what's its behavior that's not user-focused, but still depended on in other parts of your system. So setting your components up for component tests covers these two bases. And you often run these locally during development. If you're working on a component, you spin up the related component test and you do your work side by side that way. When you're writing an end-to-end test, you're actually visiting some URL on your application. A component test is not representing any particular state that a user reaches by naturally using your app, but an end-to-end test uses a visit command to bring up an actual place on the internet or a locally running server, and they tend to be more horizontal in nature. You move through the end-to-end test representing a user trying to accomplish something in your application. So things like your checkout flow or contact forms, stuff like that, are usually really good candidates for end-to-end testing because you have a bunch of things you want to make sure are functional. As you change code underneath them, make sure users can still do the core business things. Almost everything in the kind of end-to-end test that we're talking about runs through the user interface. And the most true idea of an end-to-end test encompasses the entirety of the system. So you have a real server in the back end, and you're doing things a user would do. And as far back as you can set things up, the user is going to experience the same thing that your tests do because we're actually exercising all the code. In many cases, you write stubs and mocks in end-to-end tests, and we'll talk about that later. And also, these are not things that you always run when you're developing. They can be slow. You might want to run them in parallel and just let your continuous integration process take care of running all the user flows, all the edge cases, after you've made some changes that you're already confident are worth pushing up. And then you can see if you did break anything unexpected. So we have this end-to-end testing example that we'll look at. And there's really two approaches to end-to-end testing. I'm going to switch Cypress over to end-to-end mode. And we'll take a look at this one that visits the application. I've just got a demo app running. It's just a login page. So two approaches to end-to-end testing are like manually writing them out or using some tool that records them for you. There's benefits to both. If you're manually writing out your test script, you have a lot of control over what selectors are used, what elements are going to get actually chosen, and you can see how that works so that you can make sure that it's only testing stuff you care about. If you use a recording tool, you may get selectors and things included that don't actually matter, that are just artifacts of the tool. But we're going to look at both. So in this first spec, this is the regular end-to-end test. I'm going to solo this one and run it. On the left-hand side is a log of the commands that took place in the test. So we can see we visit. We have a similar assertion to before that like something, an element that contains username, go and grab the input and type something into it. And then we're going to click the login button. And finally, there's an assertion here, says sci.contains Luke. I won't go into how all these assertions work. You can look this up if you're interested. And you can also find the equivalent in any other testing tool of like, how would you do this? But what we can see through like the progression of the test in time is that we found this field, like we typed into it, we clicked login. And just for the sake of an example, there's a call out to the Star Wars API, swapi.dev. And we can see before and after that API call succeeds, it contains Luke. So there's a little bit of a loading wait, and then it shows up the Luke Skywalker information from that API. So this is purely to have something that happens after you log in this demo app. And we have that assertion there. And so if we wanted to, we can come in and add something into this. And this is using an experimental feature in Cypress called Studio. There are whole other ways to do this if you're interested. But I'm going to say, go to localhost 3000. And I'm going to type in Test user. Test password. And I'm going to assert that this button says log out. So Cypress has saved these commands. We're waiting on the API in the first test. Okay, that's good. And I still had that set to only. So it generated this weird looking test over here. Let's run that one now. Okay, great. So the test that we recorded, you can see it looks a little different. It's not as well crafted. We're getting elements like nth child this and stuff like that. This is the risk of using recording tools because what it generated here doesn't actually matter. And there's a few different ways you can compensate for that. But I want to highlight that if you have like I don't want to call out specific examples actually, but if you have a tool that just records like this, sometimes you end up going in and maintaining them anyway and cleaning them up to look a little bit more like this stuff. But it is a great way to get a bunch of testing done fast. If you just want to have coverage right now on a lot of stuff, recording is a fantastic way to do that. And you can see it did all the same stuff. It clicked it, and we got an assertion that this thing was working. Anyway, a short while after entering the clear waters of end-to-end testing, the ship is seized again by the tentacles of the sea monster.
End-to-end tests are complicated, slow, and flaky. You'll never deliver this feature. You'll have to wait for the API team to finish before you can even start.
Get out while ye still can. Delivering quality software be too hard.
Again, you bury your head in the pile of charts, and this time you emerge with a map that shows a little area just off to the side of end-to-end tests.
Captain, it looks like we can stub the network and get out ahead of the API team, then just meet up with them at the end right before delivery. They'll go there, and we'll go here. Parallel.
Parallel. Sounds like a bulletproof way to increase velocity with no downsides. Hard to port.
We've heard this. We've all heard this at work, something very similar. Stubbing the network is, stubbing or mocking is a way to provide example responses to your application that would simulate what the real endpoints would do if you actually had your backend running, but it doesn't talk to a backend at all. There's a few approaches to doing this, but the main thing is you want the network activity on the front end to be exactly the same. In terms of benefits, this is really useful for edge cases. If you have a form that submits and sometimes there's a problem recording that form to the database and you have to tell the user, it's hard to make your server do that. But if it returns a certain status code and certain information that the front end is supposed to handle, you can provide that response in a way that's just, faked right for that moment in the test. The other part of this is this speeds up the execution of a test a little bit. Because if you're waiting for a network to respond, that work has to be done, especially if you're touching a live API that's separate. That work has to be done and has to come back, and then you have to update the UI based on that. So there's a little bit of a performance cost when you're using all of the real APIs all the time. On the right-hand side here is an example of how you would do this with Cypress. There's an intercept command. You can put a path as the first argument, and then just the object that you wish would come back in the body of that response. So we'll take a little look at that example. So this is the same, and actually let's run them both. I'm going to get rid of this test code here. So we're watching the E2E test, and you could see this little delay while we're in the loading state. Just a little slower to run than the other one. And so that's just waiting for the Star Wars API to come back and have the data in it. On this second one, I'm going to set us up to do only the second one. We're using a fixture, which is just a JSON file that we're able to reach out to. And we're grabbing that fixture and saying, hey, when I call this path here, just use my fixture for Luke Skywalker. Don't talk to the real Star Wars API, we're going to get rate limited if our automated tests are hitting them all the time whenever we run. So let's just use the fixture. And to show the example of what that fixture is doing, it's just in here, right? It's just the JSON that would come from that. And so right now, this is working. And if we were to take a look at just running that test, I'm going to refresh here to clean up the network thing. We can see in the browser, network tab, the response from this request looks just fine. It's exactly what we would have expected with the real one. But if I were to come in here and change my fixture, put in Chewbacca, we can rerun this, and we can see Cypress is like, is it ever going to show Luke? Is something coming? Is Luke happening? But it's really used a simulated endpoint, so it's just captured it and given us back what was in that fixture. So it's kind of clear why this would be faster. This already belongs to the test, and so this lets your component or your end-to-end test react as though you had this real data coming through. So this is the kind of premise of using network mocks in your tests. I also highly recommend this in component tests. If you have components that use some system to reach out to an API, mocking at the level, just letting that behavior happen and mocking the network for that behavior is so much easier than maintaining some other in-between step where you simulate a bunch of props, you prevent that behavior at all, and then you pass different props to the component. This is a really nice way to just naturally populate your component specs without having any particular kind of extra wrangling to do. It'll just kind of work. Cool, so we fixed that. Things are passing again. All right, we get back to business here. It wasn't long after entering the sea of network stubbing that the tenacious monster arose once more.
Now that you have mocked the API layer and don't need to run the API test, how will you know when the API has changed and make sure your code still works?
But the captain had been this way before.
You can't fool me. I know this one. Give me the charts. We can test our mock responses against the real API. Then we'll know if changes be deployed that would invalidate our mocks.
And so the ship set sail for the cool and calm lagoon of API testing. So API testing is sort of the flip side of that work we did with the mocking, where we're testing exclusively the UI. In API testing, what you do is you run an API and you do very like unit testing, right? You call an endpoint and you see what came back, and then you pass it different data and you make sure it's behaving correctly. So this is something that we can do to make sure the contract of the API is the same. Sometimes you might not even test all the individual properties that come back. You might just say, hey, it's supposed to have an array and it's supposed to be in this kind of format and the objects are supposed to look this way, so that you know that the API is doing the right thing. If you're isolated from the team that develops the API, this is also a pretty good way of just getting a beat on if that API is changing. It's really important if you have mocked things on your end where you want to know that your mocks might eventually not represent reality anymore. And I'm sure as you're watching that last piece, that's one of the risks of mocking that you take on. You gain some speed, but you lose a little bit of confidence that everything is still really working. API testing does not need a browser, but you can use a browser to do it if you want to. So we'll show how it's facilitated in Cypress. One way is with the sci.request. That will just make the request for you, and you can compare the response. There's also a plugin by Philip Hriss, who is fantastic, and he has made something that we'll show here, which is a way to do an API test and see some of the information as you do it. So that's a live test that hits the Star Wars API and does some stuff, and we can see what came back in here. Nothing is intercepted or mocked. We're actually just calling it. And if we do it again, we can see it takes a little bit of time to come back. So it's hitting the real thing, and we have an assertion here about a deep equal between two objects. So we'll take a look at the spec file and see what we're checking. What we're doing right now is the last one. We're going to grab that same fixture we already looked at, and we know that that's supposed to represent this API call for Luke Skywalker. So we're going to say, okay, instead of sci.request, we'll use Philip's plugin, and we'll say sci.api, pass that plugin this particular path. And then we're going to say, okay, that's called result. And then person and result are supposed to be the same. And that's our way of saying that we have, oh yeah, here it is. Yeah, that's our way of saying that this Luke Skywalker is equal to the person that came from the result. I misread that a little bit. So we're assigning the result.body to person, and we're comparing it here with the fixture to say, this object should be just like the one in my fixture, and if it's not, fail my test. And so even though there's a little bit of a wait here while this runs, we're only doing that once right now, and our end-to-end tests are already mocking that data and providing it. So if we were to start these tests at the same time, all the end-to-end ones that use this wouldn't pay that performance cost of waiting for it to come back, and we'd have still got one thing that confirms the API is working. So if you're absolutely trying to eke out like the most speed out of your tests and you want to mock a lot, this is a good fail-safe to say that, okay, well, we actually still want to hit the API and make sure it's working. You probably will also have some end-to-end tests that don't mock it at all in particular situations, especially if you don't target things in development, in PRs and stuff. If instead you're doing testing against like a staging environment or something like that, you may just have everything up and running and not need to do this. But yeah, this is what API testing looks like. There's a lot of ways to approach it inside and outside of a browser. Just helps you understand what those endpoints are doing independently of an end-to-end or a component test. Okay.
I'll still catch you somehow.
Still avoiding work. You aimlessly look through charts and logbooks until you realize something.
Captain, we're not going to make it. We're moving too slow and the monster will catch up to us again before we get to shore.
What? How? We have so many tests.
We're too heavy. We need to drop some tests to pick up enough speed to deliver on time.
Which tests are the heaviest?
The end-to-end ones, Captain.
But they provide the most confidence.
Yes, but also, according to this, they provide death at the bottom of the ocean.
We have to let some go. Keep only the most important user flows. Can they log in? Can we get paid and do the contact forms work?
Okay, so the captain's making trade-offs here. It's very tempting as you first get exposed to testing to feel like you're supposed to do everything all the time. We have all these tools available. They all protect different parts of the risk you might have of regressions or bugs creeping through to production. But there's some stuff that's more important than others. So the traditional way I've heard this expressed by a few different people is, can you log in? Can you pay for things? And can people contact you? So if users can't log in, they probably can't do other important actions, and you want to know that. If you've broken that, let's find that out before you push that code into production. Let's find it out when you're making the pull request that breaks it. These things are super important, so the heaviest, slowest tests are really worth it. But you may miss some failures in like a help page or a contact page or like an about page that are not related to these core functionalities. And that's a risk you'll often be willing to take because maybe you can cover those with other types of testing that don't take as long to run or as much effort to maintain and set up.
But what about all the other tests?
Put what you can into component testing. Maybe without running the whole full stack banking application to test an accordion, we will move fast enough.
So the trade-off here is around what are you actually doing in your end-to-end test? If you have an end-to-end test that visits a particular page and then just exercises one component into various different states, those things that you're testing might not really depend upon the user getting to that page to do that. So accordions, error states in forms, other complex interactive components, unless your test is moving between pages and doing something that really represents a user journey, you can still do health checks in an end-to-end test when you pass through that page, but it might be better to do your more intense testing at the component level. That way people will actually run those tests when they're working on the component. And it also helps to make your end-to-end tests a bit more lean and focused on the journey. Last point on this one is the isolation is a drawback of component testing. If you have issues that only occur when different components interact on the same page, it's worth covering those from end to end as well. Because sometimes, even on accessibility, like we talked about, you discover an issue that's related to the combination of components in a page environment. Maybe one thing covers something else. So I'm not saying don't touch these in end-to-end tests, but you can be mindful about how deeply you need to exercise them there.
And the network?
Stub it in all the component tests, but then we really need to keep testing the API.
So the trade-off here, like we talked about already, is testing the API with an API test is really useful, especially if you're stubbing it a lot. So Captain's going to double down here and saying, let's keep those API tests so that we can have confidence the 20 places we're stubbing those calls are actually referencing real data. And if you start those two tests at the same time, that can actually increase your total speed because you're not waiting on those in 20 tests, you're just doing it once, and the API test is like an independent thing. And you can also do things like strategically break these up so that you don't run the API tests if you know the API hasn't changed, and do things like that that uncouple your testing so you can be more efficient in deciding what tests to run.
And about those component tests,
Yes,
cut anything that checks internal methods.
but developers love testing the internals.
Throw them overboard.
The developers?
The tests. We're in a browser after all, and around here we go through the user interface.
Okay, so the trade-off we're making here is that unit testing internals of components is not necessary to do in a browser. You're in a slower, more user-like environment, but these are things users don't touch directly. So component tests work best when they focus only on the surface area. Testing the other stuff is sometimes like very common. I've seen a lot of component tests that just get into everything that the component does. But those details don't actually necessarily even make it to the user. If you're testing a computed function that tells you like a tax calculation or something, and you don't assert that that calculation is visible in the user interface, you can have a super green test with your perfect logic that doesn't actually show up and make it to the users. So separating out the business logic from the component's presentation responsibilities not only makes your tests, again, more focused and more balanced, but reduces like the risk of things creeping through even though stuff looks green. So sort of wrap up here with the sentiment of testing what matters where it matters. This is something that is different for each person and each project. This is a cat here from Cats of Yore, greatest Twitter account, now Blue Sky account that you can possibly have. And this is not something that I can give you a shape that's going to work for you. It's something where as you get into situations, and especially as bugs happen and you want to protect against them, thinking about where you want to do it is important. So you can have confidence and you can have really fast feedback and you can have a balance between what areas you need those to be in. You can increase stability by having network endpoints stubbed, but then you've added a little bit of risk around those endpoints changing on you. And so you're constantly balancing all these things. And sometimes you don't know about everything. When I started, end-to-end testing was all I knew. So I would just use it for everything. And that worked. But the bigger your projects get, the bigger your teams get, it can be harder to see the value in what you're actually getting out of only one kind of testing. So we do this carefully. The thing that we haven't talked about yet is when I did only use end-to-end tests, I found it really hard to understand if I had duplicated test coverage. If I had narrowly done the same thing somewhere else, like I write a test that goes to the contact page, fills out the form, and checks one box to say that like, oh, I want to be contacted again. So we want to check that flow and make sure we set the value in the database to contact that user so that it works. That's cool. And in that form, I might also say, I'm checking the accessibility. Do these form fields have labels? Do these other things happen? And then let's say later, there's another test that just goes through the form continually without checking that box and without asserting accessibility. And at some point, the little box to check goes away, so I delete that test that happened to have extra coverage because it wasn't exact duplication. That's one of the most difficult things to catch when you have a ton of tests. So end-to-end tests like exploring the DOM and getting distracted by these little side quests can really make it hard to understand what's actually covered just by the name of the spec file, like contactform.spec or usercheckout.spec. And it's hard to delete things safely. I really like this idea of sharing fixtures between teams. If you have a separate API team, they should know that your fixtures are being used to mock, and they should be able to give you some heads up if those fixtures can be actually used as a reference point in both teams and both sets of tests. This is a really good way to avoid regressions sneaking in between releases about separate teams. But definitely most importantly is to help each other out, talk to the other teams. I had somebody who was a QA engineer who talked to me after a talk once, and they wrote end-to-end tests, and they had spreadsheets for locators, and they never really talked to their development team. And if you're familiar with data IDs just for testing, you can have an attribute on an element that's like data test or data sci login. And engineers do this on components so they can maybe get them with React testing library or get them with Jest or Cypress component tests. But the QA folks I was talking to, they were like, these are great. We love test IDs when we see them. I think that's a React thing because we're using React. And I was like, no, your engineers do this for their tests. If you ask them, they will also do this for you, and you don't have to maintain your big spreadsheet that has all these selectors that you have to update when the UI changes. If you work together with the development team that's making these things, they can definitely make testing easier and more maintainable. Anyhow, as the day of delivery draws near, the final destination is in sight, and the tentacles of the sea monster recede over the horizon. The crew sheds a collective sigh of relief at last. All except the captain, scanning the empty seas in every direction with a telescope, looking for the ship you were supposed to meet.
How's the API team doing, Captain?
I'm not sure, but I think they're still trying to figure out how to turn on their computers.
Okay, that is that. Thank you very much to Cecilia, Will, and Abby. Let's give them a round of applause. I have two links on here. One is for the slides. The other is for this accessibility tooling that's being built into Cypress right now. So I'm sort of full-time working on that from a product perspective. If you're interested in accessibility, I would love to talk to you about it and maybe set up early access or something. Yeah, that's great. Thanks so much.